Good evening, folks. I've just found a really good resource for studying. I think it's got truss analysis stuff on it too, so I will be having a look at that in a moment. But this is a free program that allows you to analyze beams. And what you can do is you can hit add beam here. I'm going to do a 10-meter beam. The reason why I've sorted this out is because I was having trouble with cantilever beams. I was finding that when you were dealing with a cantilever beam that was pointing to the right, you ended up with a shear force that was a positive, and I was dealing with cantilever beams going to the left, and it was a negative value, and I was just thinking, well, how can that be? Just because it's facing a different way, you get a different value. But that is actually what occurs, and the way I've actually worked that out, of course, is I've used this program to actually construct it, and it will build a graph for you. So you can use this program to build different beam setups with different supports, and then you can do the working out and see if you are correct by pressing solve. So at the moment here we've got a 10-meter beam. We can add a support, and I'm going to add a fixed support because this is a cantilever beam, and I'm going to put it to the right 10 meters. So when I say add it, now we've got the support to the right. I'm going to put a point load, add point load on the end, so I'm going to put that at 0, and I'm going to do a 20 kilonewton point load, and all we have to do now is go up here to where it says solve and press solve, and after our little wheel does its spinning, it gives us a reaction force of 20 kilonewtons at the wall. It gives us the reactive moment. This beam wants to drop this way, so we need to have a reaction at the wall that goes in the opposite direction. That is 20 times the distance of 10. That's why we have 200 kilonewton meters. And if we go down here, lo and behold, we have a shear force diagram that is negative. It's below the 0 because the beam is going to the left. I'll do one to the right to show you to the right to prove that it becomes positive. So this has confirmed what I actually thought. And the thing that you'll find with the top a cantilever beam that's got a point load pointing down towards the ground is the bending moment is 0 at the free end, and it's maximum at the wall, and that happens for both beams in both directions. So this diagram here, the bending moment diagram, doesn't change if it's going left or to the right, but you'll see that this shear force diagram does change. So we'll just quickly hit the reset button, and we'll go again. So I have to find the reset button here. Undo. I thought there was a reset button. Obviously there isn't. So we add a beam, and we make it 10 meters again, and this time we add our support, which is a fixed support. We're going to add it at 0, which means the beam is now going to the right instead of to the left. We're going to add our point load at 10 meters, 20 kilonewtons. So exactly the same setup, but just in the opposite direction. And then when we hit solve, lo and behold, our shear force this time is positive rather than negative. And you can see here that once again the bending moment is strongest towards the actual wall, going up to 0 at the free end. So as I suspected, some of the information that I've been finding online has been incorrect. They do mention in the textbook on page 35 that the shear force diagram for a cantilever can be either positive or negative, but the bending moment diagram will always be negative, but they don't actually tell you why or describe how it happens. So you can actually use this program here to do lots and lots of different designs. You can do the working out, and then you can actually see if you've actually got it correct. So it's a very handy program to play around with different setups. Anyway, I'll leave it at that.